Now we look at this triangle. We're given that this distance is 1.2 meters. This is 41 meters and the angle is 20 degrees. We want to find this altitude here. Okay, you might stop and think, how would you use what we know about the tangent function and so forth to find this altitude from this angle and this distance? Well, it turns out that in the first place we've got some superfluous information. This 1.2 meters is not needed for anything. This is the kind of thing we would get if we were measuring a flagpole maybe, and maybe we would have used this to get this angle, but after that we don't need it at all. The tangent of 20 degrees then is the unknown side over 41 meters. Okay, because the tangent is the side opposite the angle divided by the side adjacent to the angle. So that this unknown side is 41 meters times a tangent of 20 degrees, or 14.92 meters. And that is a very straightforward calculation. Once we write the fact that the tangent of 20 degrees is the unknown side divided by 41 meters. Here's another situation. Another red-eyed ogre situation, apparently. We know that the tree on this side of the chasm is 42 meters high. Our line of sight makes an angle of 35 degrees with horizontal. So the question is, how far is it from here to here? Okay, you should solve this equation, or solve this problem, solve this situation before you look further. Now, if we write out the definition again of the tangent function, and the tangent function is appropriate because we have the side opposite the angle and the side adjacent to the angle. The tangent of this 35 degree angle is 42 meters over the unknown side here. Solving for the unknown side, we multiply both sides by the unknown side, divide by the tangent of 35 degrees. We get 42 meters over the tangent of 35 degrees. And if you calculate that, you might come out 59.98 meters. Now really the 0.98 is not significant. If this is just 42 meters to the nearest meter, then we'd say this is 60 meters to the nearest meter. We're being a little careless with significant figures here. But I did want to show you the result that people reported from class. One more example of a triangle. We have this situation where we have another red-eyed ogre. Somehow we know that this distance is 82 meters. Perhaps we flung a string up to the top of a tree that we know is 15 meters high, and we measured the length of the string, not having anything to measure the angles with. We had to fling the string up here, because if we fling it down here, the red-eyed ogre will just grab the string and break it. So we have to throw it above his reach. Okay, so what do we know? We know this side and this side. How can we determine, let's say, this angle and this angle? We know this angle, of course, to be a right angle, assuming that it's a vertical 15-meter tree. So solve this problem before you look further. And now let's take a look. Okay, this side here, the question mark side, we're going to call A, and we're going to say that A squared plus A squared equals C squared minus B squared, where we let this side be C and let this side be B. This angle will be large B, this angle will be large A. You probably can't see that large A, it's there. We can probably see if we zoom back just a little further, we'd probably still read everything. Okay, so we're going to say that again, that since A squared plus B squared equals C squared, A squared equals C squared minus B squared, and then we easily find A to be 80.6 meters. So this distance is 80.6 meters. We then say, okay, tangent of the angle B is going to be the 15-meter altitude here, the opposite side of the angle B. Again, we're looking at angle B. We're going to say tangent of B is 15 meters over side A, and we found that side A was 80.6 meters. So tangent of B is 15 over 80.6. B is the inverse tangent of that. 10.5 degrees, and then A is just 90 degrees minus that. Since we have a 90-degree angle, these two angles, A and B, add up to 90 degrees, so that A will be 90 degrees minus B. That gives us 79 degrees.